Hello, good morning, student. Today we are going to discuss about the protection and deprotection of amino groups. What did we learn yesterday? Yesterday we learned about Bach is one of the protecting group used to protect the primary amine as well as secondary amine, because primary amine or the secondary amines, these are the functional group present along with carboxylic group in the peptide synthesis, and therefore these are the groups are very important, or these are the reagent used to protect the amino group. The main purpose of protecting this group to make the reactivity of that particular group is less, and then the reaction carried out at the other center, and after getting desired product we can deprotect it by using proper reaction condition without affecting the other functional group, and in this way we are getting the desired product in the organic reaction. So that is the main purpose or the significance of this protection and the deprotection. So today we are going to discuss the fifth important protecting group. The name of that fifth protecting group is 9-fluoronyl methyloxycarbonyl. It is in short known as F-MOC. You can pronounce this F-MOC in short. So this F-MOC used to protect the primary as well as secondary amino group in the organic synthesis, and therefore in short you remember, or that is a F-MOC, and the full form of that F-MOC is nothing but 9-fluoronyl methyloxycarbonyl. Now what will be the structure of that 9-fluoronyl methyloxycarbonyl? This is one of the carbamate. Carbamate means whatever protecting group we have learned so far. One main is a CBZ group, second one is a BOC, and third one this one. All are the protecting group of amines, primary or secondary amines generally. And now let us see the structure of 9-fluoronyl methyloxycarbonyl. The structure is, this is the structure. Remember the structure here. This is a structure of, this is a structure 5-membered ring. Is it a 5-membered ring? A1, 2, 3, 4, 5, yes. And therefore, and here this CH2, then O, then C double bond O, then Cl. So this is a structure of 9-fluoronyl methyloxycarbonyl F-MOC. So this position is a 9, and that's why it is known as 9-fluoronyl methyloxycarbonyl, that is pronounced as F-MOC, F-MOC. So that is a protecting group, and when this protecting group generally used to protect the primary or the secondary amines. Let us see how it is protected, under what condition it is protected. Under the basic condition, it is protect the main speciality of this 9-fluoronyl methyloxycarbonyl F-MOC. It is introduced under mild basic condition, as well as it is removed under mild basic condition. Means it is very stable at oxidizing as well as reducing as well as in a acidic condition. It is a very stable, and therefore remember, this is a group. In a previous two example we have seen CBZ and the BOC. They are introduced under the basic condition, but they removed under the acidic condition. But in this case, F-MOC is different than the previous one, because it is introduced under a basic condition as well as it is removed under basic condition. So that is a speciality or the main feature of that 9-fluoronyl methyloxycarbonyl means F-MOC. Now let us see the example here. Suppose we have an example here starting about RNH2. This is a primary amine I am taking here, and this will be treated with Cl, C double bond O, then this CH2, then 5-membered ring attached to with this 6-membered ring here like this, and you can, in short, you can write that benzene ring. Or now what is going to happen here? Under the basic condition, normally triethylamine, or you can use as a pyridine as a base here, and what is going to happen? This lone pair which is present on it is going to attack over there, and you are going to get here the product RNH, then C double bond O, then this CH2, and then this one is a 5-membered ring always, and then attached with the 6-membered ring. In this way, simply you can draw the structure, or in short we can write this one RNH F-MOC. In short you can write as this way. This is the simplest way to represent this structure. Now after this is a protecting group of amines, and this protection is protection used with the F-MOC. Now deprotection can be carried out with in a basic condition. You can use here triethylamine in presence of maybe as a palladium chloride, or you can use as a base like sodium hydroxide in presence of CH2Cl2, dichloromethane as a solvent here. So in this way we can deprotect it, and you will get your NH2 group is free as it is, whereas the side product you are going to get carbon dioxide, which is a gaseous in form that goes in the atmosphere, and the side product again you get here this one 5-membered ring, and then this attached with that 6-membered ring, this one. So this is a side product we are getting here. So this is a simplest representation of this organic reaction. Main thing you should remember here, this group is introduced under basic condition, as well as it is removed under basic condition. That is a speciality of this group. Now let us look at the mechanism of this, how the mechanisms takes place here. Let us see the mechanism of this. Now let me during that mechanism, let us take the example here. This one, mechanism of protection. First one, mechanism of protection. Observe the reaction carefully, how I am showing that arrow. Similarly, you can draw that arrow. R NH2, it is treated with pyridine as a base. What it will do, base will abstract one of the proton from here, and when proton goes along with that pyridine, it leaving the bonding pair here, and so that we are going to get R NH minus charge over there, right? This is a minus charge present on that nitrogen atom. It is further treated with the F-MOC. This one, the structure of F-MOC, we know that this is a CH2 group attached to 5-membered ring. First you draw so that it will become as easy to and then fuse the benzene ring to this, like this, above side and below side. You can circle it, that is a benzene. So this is a structure of 9-fluoronyl methyloxycarbonyl, or in short we can call it as a F-MOC, right? This is a F-MOC. Now what is going to happen? This negative charge is attacking on this carbonyl group. This double bond revolving around it, and there is a departure of leaving group, and the structure we are going to get here. What do you get here? You are going to get R, then NH, then this one C double bond O, CH2, then this attached to with that 5-membered ring, and then attach benzene ring on both sides. That will be the simplest way to represent, or in short we can write here R NH F-MOC, right? F-MOC. So this is a way to represent this one, that is a mechanism of protection. Now let us see the mechanism of deprotection. Next one is a mechanism of deprotection. Mechanism of deprotection. Let us take down this example. Here again R NH, then C double bond O, then this CH2, then draw this middle one 5-membered ring, then connect, join one benzene ring here, another benzene ring on another side. That will be the structure of this. Now what is going to happen in deprotection? Normally we are using as a base sodium hydroxide. Let us see here, sodium hydroxide, or maybe as a pyridine you can use ET3 triethylamine. So triethylamine, what it will do, look at here, this CH2 group, benzylic type of the this looks, but it is not the benzylic, because it is here, it is this CH2 attached to that sp3 carbon atom, and therefore it is not the benzylic. In a benzylic we can easily cleave the heteroatom by using the hydrogenolysis, H2 in presence of palladium and charcoal. But that is not the case here, because here we are using as a base, and as we know that the function of base to remove the acidic proton. Here this is a acidic proton, and this acidic proton will pick up by this base and form here as a carbanion ore. Observe this reaction carefully. This pyridine will pick up the proton, and this bonding pair living here forming as a negative charge. That carbanion is well stabilized due to the two benzene ring present over there, and that's why you are going to get the structure here R, then NH, R, NH lone pair as it is, then C double bond O, then this CH2, then this one 5 membered ring, this one, and here joined with that 6 membered ring benzene, and you are going, now here is a negative charge over there. Now when this negative charge form over there, what is going to happen? Further, this negative charge forming as a double bond over there, and this bond get cleaved, and we are going to get here R, then NH, then C double bond O, then O minor charge lone pair which is present over there, and then we are getting here double bond 5 membered ring. So not this, that is a double bond, then 5 member ring, and that 5 membered ring on both sides there is a benzene ring fused. So this is a structure. Now finally in the workup, what is happening? This negative charge forming double bond over there, and this can pick up. Here we are going to get R, NH minor charge, and plus what is that? Carbon dioxide evolved during this process, and then in the workup this negative charge will pick up the proton from water, and finally you will get R, NH2. It is a amine we got back as it is. So this is a representation of the mechanism of protection as well as mechanism of the deprotection. Now moving toward the next point, let us see here general, suppose we in a peptide synthesis, let us see one of the example how it is used there, or it is widely used in the synthesis of peptide, in a peptide synthesis. So let us see one of the amino acids are there. Let us see, you might be knowing this is one of the structure where we can get here C double bond OH, and this NH2. What is this? This is known as a alanine, right? Let us see here in this structure there is a carboxylic group as well as amino groups are there. If you compare the reactivity between these two groups, what do you see? Here NH2 group is a more reactive as compared to the carboxylic group. The reason behind it, here nitrogen atom is a less electronegative than oxygen atom, and oxygen atom is more electronegative in nature, and due to the its tendency to hold the electron more tightly, and but in case of the nitrogen atom, the lone pair which is present on that nitrogen atom, they are readily available for donation, and therefore it get protected first with that F-MOC. F-MOC means Cl double bond O, then this CH2 5 membered ring, remember, and then benzene ring joined here. In this way we can draw this one. Then NH2 is directly attacking over there, departure of that chlorine group. In short, we will get here, I am writing pH, then this one NH F MOC. In short, we can write C double bond OH, right? And this is a protection. And whenever you require, whenever you can carry out the reaction, suppose if you treat with that thionyl chloride, you will get as acetyl chloride, that becomes as a more reactive one, then further treated with another amino acid, so there is a formation of the peptide bond. And whenever you require deep protection, it is easily carried out in a base, and you will get your original compound original pH, then pH, then this one C double bond OH and the NH2, and side product will be the carbon dioxide as well as this double bond 5 membered ring, then fuse with that benzene. You will get this type of the final structure, right? Understood? This is one of the example which can clearly explain what is that 9-fluoro-methyloxycarbonyl is FMOC, and these are the example we have seen. I think with this we have covered whatever protecting group which are included in your syllabus from this year. So we all are covered as far as amino group. First protecting group we have seen benzyl chloride, acetyl chloride, third one is a CBZ, fourth one is a BOC, and fifth one is a MOC. So some of the other protecting group for the amine group, that let us see some additional information as far as these amino acids are concerned. Let me explain that also, so that you will be you can understood that group protect, because we are talking about protection and the deprotection. First one is a phthalate protection. First one, some other example now we are talking about. Some other, so that is a phthalate protection. That is a phthalate protection. Phthalate protection. Here I am just giving you the how that protection is carried out and how deprotection is carried out by using this type of the special some of the other group which can protect the primary as well as secondary amines. Now this phthalate protection, generally let us see, suppose we have a starting compound is a primary amine, and that primary amine will be treated with phthalic anhydride. As we know that the structure of phthalic anhydride is this one, phthalic anhydride, benzene ring, you can know that is a benzene ring, then C double bond O, then phthalic acid is treated at high temperature or in presence of Al2O3 or in presence of concentrated H2SO4, dehydration takes place because they are the dehydrating reagent. The dehydrating reagent means to remove the water molecule, and we are getting this type of the anhydride. So this is a phthalic anhydride here. This is the amine. Starting compound is a amine. This is a phthalic anhydride. Phthalic anhydride, when it is heated, introduced, heated, and the solvent is used as a chloroform here, and chloroform is a volatile solvent. Still the reactions are carried out at room temperature or maybe at the lower temperature, what do you get? You are going to get here the product R N, then double bond O, then this one you are going to get. This is a protected phthalate protection. This type of the thing is called as a phthalate protection, and deprotection can be carried out by using NH2 in presence maybe as a ethanol. This is known as a hydrazine, right? Hydrazine, and that hydrazine used for the deprotection of that thalamides type of the compound, so that you are going to get here back RNH2, which is starting compound. After the deprotection we are getting that functional group as it is, and you are going to get here NH, then C double bond O, like this is a benzene ring. That type of the product you are going to get here. So this is a first one we have seen here, phthalate protection. Phthalate protection is introduced under this heating process, and then chloroform we are getting as a protecting group like this, and deprotection can be carried out by using hydrazine, and you will get deprotection very easily, and these are very stable under the basic condition. So this is all about the phthalate protection. Now move on to the next one. Second one is known as, what is that? Benzamide protection. Second one is known as a benzamide protection. Benzamide protection. Benzamide protection. In the benzamide protection, this benzamide generally is protected under the basic condition, whereas the removed under the strong acidic or basic condition, vigorous reaction takes place, or sometime it is removed by using hydrogen bromide or the sodium hydroxide. That is a benzamide protection. Let us see here. Suppose we have a starting compound is like this, secondary amide then RR-NH, then it will be treated with pH C double bond O Cl. This is called as a benzoyl chloride, and this benzoyl chloride is introduced under basic condition. Base will abstract the proton from negative charge, and this is going to attack on that benzyl group like this, and you will get the product RN, R dash, then C double bond O, PH. So that is called as a benzamide protection, and this get protected. Now it is removed under, we can use strong 6 normal hydrochloric acid, or we can use as a hydrogen bromide, or we can use as a sodium hydroxide, the strong bases, and they are stable under oxidizing or the reducing reagent. After using that one, what is going to happen here? RNH, then R dash, and side product may be as a, suppose if you use as sodium hydroxide, you will get this one, benzoic acid, as a side product. So this is a second point which we have discussed here. It is used as a protection for amines, primary or secondary amines. Now moving toward the next point is amine acetyl derivatives. So third one, let us see here. Third point we are discussing here, that is amines acetyl derivatives. Amines acetyl derivatives. Amines acetyl derivatives, this also introduced under basic condition and it is removed under some Lewis acid. So let us see here. Suppose we have a general R dash secondary amine, this one secondary amines, and this further treated with MOM, means methoxybenzyl chloride, right? MOM, you might be knowing MOM is this one, CS3O then CH2Cl in presence of sodium hydroxide, in presence of base will abstract the proton from here and you are going to get the product R, then N, R dash, then CH2O, CH3, or in short we can call it as a MOF, and this will be removed under, if you use here BF3, that is a Lewis acid in presence of diethyl ether or acetic acid in presence of lithium bromide, acetic acid in presence of lithium bromide, you will get the D protection very easily, and we will get as a R, then N, R dash, H, and plus this one, whatever side product is there, but we got as a our main product is produced here or generated here. Now the fourth point we are going to learn N-benzyl derivatives. Last one of this amine group is a fourth one, because these all are the other protecting group which is used for the protection and the deprotection of amino groups. They are also as a some important as far as in your if you go for higher study, so yeah, it will be helpful to you or it is beneficial to you. That is fourth one, N-benzyl derivatives. N-benzyl derivatives will be introduced under basic condition and it is removed under the hydrogenolysis. Now let us take down as an example R, then N, H. It may be as a secondary amine again. Secondary amines further treated with, we know that benzyl chloride BnCl in presence of K2CO3, potassium carbonate act as a base here and negative charge form here, and that negative charge is going to attack on that benzylic carbon atom. Cl get removed, one Cl from here and hydrogen from here, SCl goes in the atmosphere and you are going to get as a N here R dash, then benzyl, right? Bn means pH CH2 pH, that is a benzylic group, and that benzylic group, as we know that, or in short you can write here R, N, R dash, then CH2, then pH, right? And this group, after you hydrogenases H2 palladium in presence of charcoal, what is going to happen? This bond get easily cleaved or heterolytic fission takes place and we will get R, NH, R dash and plus toluene CH3 pH, that is a toluene form here. Toluene is generated as a side product in this case. So in this way we have covered so far two main functional group. One is a hydroxyl group, second one is a amino groups, right? And in a hydroxyl group we have seen phenolic as well as alcoholic as well as 1,2-diol, 1,3-diols, and here in amine mainly as a 5 protecting group we have learned. In addition to that, these 4 are the additional protecting group which is also used for the protection of the amino groups. So remaining functional group we will protection and their protection we will learn or we will discuss in our next lecture, means tomorrow's lecture. Let us stop today here. Thank you. Have a nice day.